Hello, good morning to all of you. I am Dr. D.D. Sawant from Department of Geography, J.A.T. Arts, Science and Commerce College for Women, Malegaon District, Nashik. Today's topic, that is a drainage pattern. As everybody is knowing that spatial relationship of all streams within a drainage system is known as drainage pattern. Drainage pattern refers to the particular design which the individual streams course collectively forms. Initially, water moves downslope in a thin film as sheet flow or overland flow. This surface runoff concentrates in rills or small scale indentions, which may develop into gullies and streams courses. The resultant drainage pattern is an arrangement of channels which is determined by slope, differing rocks, resistance, climatic and hydrologic variability, relief of the land, and structural controls imposed by the landscape. The most common drainage pattern encountered in nature are discussed. Number one, that is a dendritic pattern, which is as like as tree. It is type of drainage pattern which develop as an entirely random network because of the absence of structural control. Thus, a dendritic pattern will be characteristics of terrain which is of uniform lithology and where faulting and jointing are insignificant. For example, massive crystalline rocks or thick clay plains because of his branching nature of the stream network has been termed dendritic from the Greek term dendron, means the tree. The streams in this pattern follow the regional slope and therefore such streams were called as insequent by Davis. In this pattern, the tributaries do not meet the main stream at right angles. It was coined by I.C. Russell in 1898. It is the most common type of drainage pattern and is the distinctive features of regions having horizontally bedded sedimentary rocks or massive igneous rocks. As the second pattern, that is a trellis pattern, it is a rectilinear pattern formed where two sets of structural controls occur at right angle in a trellis drainage pattern. The river forms a net-like system and the tributary stream of each class flow roughly parallel to each other. The trellis drainage pattern develops in areas where hard and soft rocks occur in a roughly parallel bands. The consequent stream means the main river follows the direction of general slope, while the tributary streams flow in the direction of strike and meet the main stream at right angles. The trellis drainage pattern is well developed in the Appalachian region of USA, where hard and soft rocks are found in alternate bands. This may be found in certain glaciated areas where parallel hills known as drainage drumlins give rise in this pattern and also to some degree in areas of parallel sand dunes. If suppose drainage lines exist on such permeable material, then the pattern which is barred is the next pattern. A pattern of drainage in which the confluence of the tributary streams with the main river is characterized by a discordant junction, as if the tributaries intend to flow upstream and not downstream. The pattern is the result of capture of the main river which completely reverses its direction of flow, while the tributaries continue to point in the direction of former flow. Next flow, that is a rectangular flow, a pattern which is a network marked by right angle bends and right angle junction between tributaries and the main stream, and hence thought to be developed from the structural control imposed by the jointing or fault pattern of the underlying rocks, if differs from the trellis pattern in so far as it is more irregular and its tributary streams are not as long as or parallel as in trellis drainage. The typical example of this drainage pattern may be found on the coast of Norway. It's a pattern of overflowing rivers away from a central point, analogous with the spokes of wheel. Another pattern, as we see that in this drainage pattern, the subsequent streams follow curving or arcuate courses prior to joining the consequent stream. This results from a partial adaptation to the underground circular structure. For example, dome-like igneous intrusion, which is called as a batholith, is an example of structural guidance. The subsequent streams find it easier to erode the concentric glacier resistant strata. This type of drainage pattern exists in the Henry Mountains and the Black Hills of USA. Parallel pattern. This pattern consists of parallel master and tributary streams, pronounced slopes, parallel falls, and parallel topographic features such as drumlin and lateral moraines are favorable to the development of this type of drainage pattern. So hence this is a uncoordinated pattern of drainage characteristics of a region recently vacated by an ice sheet. This is probably due to the irregularities produced by the glacially deposited materials. Hence the marshy lands, as this is probably due to irregularities produced by the glaciated deposited material, for example, cane and kettle terrain, and by the fact that there has been insufficient time for the drainage to become adjusted to the structure of the solid rock underlying the glacial drift. The picture is one of the numerous water courses, lakes and marshes, some interconnected and some in local drainage basins of their own. So as the rock pushed up into a dome mountain forming ring-like escarpment will form a stream pattern. So here, depending on the structure and slope, the streams flow in different directions on the basis of the direction of flow as well as the direction of slope. The streams may be classified into consequent stream. Second one, that is a subsequent stream. Number third is a resequent stream. Number fourth one is a obsequent stream, and number fifth one, that is a braided stream. So like this way, these are the various types of streams which are given, and hence the beside a river that has been able to maintain its direction of flow despite the tectonic upliftment of the land across its course is known as the antecedent or inconsequent river. Thank you very much for listening.